Discussing about the Thevenin's theorem and Norton's theorem verification. In Thevenin's theorem and Norton's theorem, combinedly we have to verify. How we have to verify? First we have to see the circuit diagram. First we have to take the 8 volts battery. 8 volts battery we have to take. These are the patch cards. Power supply positive to positive we have to give. Power supply positive to positive. Now we have to apply 8 volts. How we have to apply? Power supply positive to positive, power supply negative to negative we have to apply, correct? Okay. Now we are applying how many? 8 volts we are applying. How many volts? 8 volts we are applying. Once we are applying the 8 volts, we have to stop this. Now we are going to connect the circuit diagram. First we have to take the multimeter, right? So from this multimeter, what is going to discuss about this multimeter? Once you have to see multimeter, right? Multimeter, first we have to take 3 resistances. One is R1, R2, R3. First resistance 220 we have to take. What is that value? 100. 101. Next, this one 101 is the R3 resistance. Next you have to see what is that value. What is that value? 330. 330 is R3. Remaining is 220. Once you have to check what is that value? 219, 220. So now 220 we have to take. This is the 220 resistor. 220 resistor I am keeping. Clear? 220 resistor I am keeping. Where we have to keep? Power supply positive to 220 resistor we are giving. Power supply positive to 220 resistor. Later, same, once you have to see the circuit, here R2 is there, R3 is there. R2 is 100, this is the 100 now, red, black, 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 correct? Red, black, black, black. So this is the 100 now. 100 R3 I am giving to ground directly. Ground direct. Next, this one is the 330. 330 also I am giving here. 330 I am giving. At this, 3 resistors are connected in one place. This is the vertical connection. Once you have to see vertical connection. The same line I am connecting. Same line. Vertically I am connecting. Right? Because our breadboard is in these boxes vertically connected. Here horizontally connected. Aluminum casing is vertically, aluminum casing is existing. Now 332 milliamps is there, milliamp positive. 332 where I have to give? Milliamp positive, right? Milliamp positive. Milliamps negative to where I am giving milliamp negative to? Here one junction is there. Here one junction I am keeping. This is the junction, right? One junction I am keeping. Right, from junction which one is there? One is the load resistance, one is the load resistance is there, terminal, and another terminal you have to give to the ground, right? Next, which one? Voltmeter are there. 2 patch cards you have to take. 2 patch cards, one is negative, another one is positive. So this negative is going to connect it to the ground, negative is going to connect it to the ground, and positive we are going to connect it to whom? Wherever the milliammeter and load resistance is coincide, there we have to connect. Where is milliammeter load resistance is coincide? Here milliammeter and load resistance is coincide. This is the junction. In this junction we are connecting. Clear? This is the circuit diagram. Once again you have to see the circuit diagram. First, battery positive you have to give to the 220 ohms, and then at 3 resistance we are coincidence here. How many grounds are there? Once you have to check it. Power supply negative also is there. Power supply negative also we have to give to the ground, right? This is the horizontal connection. Horizontal connection. That's why we are giving the horizontally we are giving. Horizontally we are giving. This one is vertical connection. How many grounds are there? Once you have to see 1, 2, 3, 4 grounds are there. Power supply negative is ground, R3 end is ground, load resistance end is ground, voltmeter is ground. Clear? Once completed the circuit, what we have to do? First you have to apply the power. So once we have to apply the power, you uh, tightly fix it. So one more key you have to take. Tightly fix it. Tightly fix. What will happen once you have to see? You tightly fix. Then there is a current. It will come. That current is the Norton's current. IN. How much current is there? Norton's current. That is IN. IN we have to take. This current is 6.5 milliamps. That is the Norton's current. Once we have to remove 50, you have to remove first. Take the voltmeter reading and ammeter reading you have to write. 100 you have to take the voltmeter reading and ammeter reading you have to write. 150 you have to take voltmeter reading and ammeter reading you have to take. 250, 300, 450 and so on you have to take, right? Once you have to take and you calculate these values, after taking these values, first theoretically you calculate. What theoretically you calculate? Theoretically VTH is equal to V into R3 is divided by R1 plus R2. 1 VTH it will come. RTH is equal to R1 R3 is divided by R1 plus R2 plus R3. By using these formulas, theoretical RTH, theoretical VTH, theoretical IN values we will get it. Clear? After that, you have to take the graph I0 versus V0. You have to take the graph. From this graph can come like this, negative slope graph it will come. You extrapolate, the y-intercept point is VTH it will come. Clear? Next, one more graph you have to take. I0 versus RL values you have to take the graph. Wherever the x-axis intercept is there, no, that x-axis intercept is IN and y-axis intercept is RTH is here. These are the practical values. These practical values you have to compare with the theoretical formulas values. You will get the approximately same value. Therefore, your Thevenin's and Norton's theorem is verified. What we have to write in the result? The theoretical and practical values of VTH and RTH coincide and therefore the theorem is verified. So this is the theory of the Norton's and Thevenin's theorem. So please share and subscribe our YouTube channel. Thank you.